Okay, welcome on in, everybody. I think we are ready to go. Let me make sure I don't accidentally have any tabs open with people's information. Okay, I had the roll up because I was checking roll before class, but it's not up, so I won't accidentally click it and expose everyone's 900 numbers. Right, so if you are, I was kind of doing roll beforehand with people who were in the Zoom meeting because I could see names, and so I got a bunch of people there. If you're on the YouTube stream only, please, you don't have to write your full last name if you have privacy concerns or anything. Just give me your first name and the first letter of your last name so I can get everyone marked down as roll. That's only if you're only in Zoom. If you're in both, then if you're only on the YouTube stream is what I meant. If you're in Zoom, I probably got your name from the participants list. But if you're on the YouTube stream only, throw your first name and first letter of your last name up there so I can mark you down as being here, please. So, okay, let's see. Okay, and I'll check in a little bit later. Let's see, okay, I got that. Okay, and you continue to do this. Okay, great. So I'll give people a few more minutes to pile in, and then I'll call off the people I don't have marked, so we can take care of that. Do need to check something on one of these names. Let's see. CCQ, I'm not seeing you. Do you have a different name or something that this would be under? Or feel free to stick around and talk to me after class, but I'm not finding you on my list. So we need to take care of all of this stuff before census. So if it's a different name or if you want to talk to me after class about it, we can take care of it then. But I have to take care of it before census. Otherwise, you may end up not being in the class until I can get all that stuff figured out. Okay, thanks everyone. Oh, I saw my gum. Hold on. Okay, so here we are. So I know it's been a while, right? Kind of a weird start to the semester. We got someone in chat here. Oh, I know that's another name. Let's see. Great. Okay. All right, I got you, Catherine. Thanks. Oh, added from the wait list. Oh, okay. Oh, right. Thanks, CC. I got you. Okay. So you're here. I forgot this class had a wait list. Most of our classes have been grossly under-enrolled. If you look at the schedule, like at least 50%, and sometimes like 60% of the classes are like barely have enough people to run. So I forgot to check the wait list. So thanks. Thanks, Cece. Let's see. Allison, does it have your last name? Do you have a last name I can look for, Allison? Okay, let's see. There we go. Okay, gotcha. Okay, thanks. That was everyone cooperating was very helpful. That was quicker. And then I'll just, here in a little bit, I'll just double check the names I don't have written down, which is only a few, so that's good. We have pretty good attendance so far. That's great. So keep that up. Keep attending. It's going to be important for success in this course since we only meet once a week. And then this is the one that's, this is the one that's going to be Zoom all semester, right? Yeah, so definitely important to be there for those meetings when we meet up like this. So a couple things I wanted to remind you of. And if you have questions, feel free to let me know. But I know it's been weird. We met the first week of school, and then last week was a holiday. So this is really kind of like day 2 of the semester, but it's week 3 really, right? So we're moving things along. And so I have to point out a couple things. Please don't feel like I'm scolding anyone. I'm not. There's deadlines we have to hit by the end of this week. Otherwise, I'm going to have to drop people. So I'm not telling anyone they did a bad job or anything. I know it was a weird start to a semester, but at the same time, you'll want to take some steps to make sure you don't get dropped from the course. Some of you are great and in great standing, and then others of you have a little bit of work to do in order to get caught up. So last time we talked, it was mainly just about how the class is going to work, how everything goes. I've had some follow-up questions. I'm still working on taking care of the textbook issue. I'm now in contact with the publisher, and they're setting up an appointment to help figure out why something isn't working quite right. Luckily, that's the stuff we don't use till the second half of the semester, so no sweat. We'll have it in place weeks and weeks before we ever need that. And then I can share that information so everyone can make sure they're prepared for that. So don't worry about any of that. That'll all get taken care of. The thing you should be working on now is the Delta Math assignments, and I can't pull it up because, I can't pull up the grade book because then obviously it's showing people's grades, which would not be appropriate. But a number of you have started working on assignments. That's fantastic. That is great. Keep that up. Many of you have not started any actual assignments yet in the Delta Math. You're going to want to do that because, so the end of this week, the end of the 3rd week is that census. So basically Thursday of this week is when I start looking at dropping people. It could be as early as Thursday. I could start dropping people from the course because that's when I'm supposed to start doing it. Basically like Thursday through Sunday, I have to do those drops. So that doesn't mean you should wait till Sunday to do stuff because I might drop you on Thursday. And then you won't be around to do any of the other work, and then we can't add you after census. If you get dropped, like you don't get back in because then we don't get money for teaching you, and then we can't afford to run a school that way. So I'm just making sure everyone understands what they have to do to make sure they don't get dropped. So attendance is great, which I'll verify the few absent people in a few minutes. Attendance is good. Keep that up. Also, there has to be some progress in the work. So some of you have not done any assignments. Start doing some assignments. I'm not saying you have to get totally caught up by Thursday. You don't. But you have to show, I have to be able to make the case that you're progressing in the course at census. Otherwise, I have to drop people, right? The deans will, there could be a situation where I'm sitting there and the dean is like, why didn't you drop this person? They weren't doing any work at all. And I'll be like, I don't know. So you have to do some kind of work, right? So get in there, do some of the homework assignments, try to make progress in it. If you've been attending and I see that you've been at least progressing in the homework, then I can make the case not to drop you, okay? But if you haven't been attending or you haven't been doing homework, then I'm supposed to drop you from the course because you're not really making progress, right? So don't panic today. Today's Monday. You have till Thursday to show some scores there in the homework. But, some of you have zeros all the way across. And I know, again, we're sort of, this is really kind of like day 2. So some of you might be thinking like, well, we haven't really had time to get into it, right? We kind of haven't, but census is here and I have to drop people contractually. So, please get a few homework assignments at least under your belt. Those of you who have done that, great. That's those of you who've already been doing it, you're really setting yourself up for success in the course. Keep that up, and you'll do just fine. For those of you that haven't done it yet, that doesn't mean you're not going to do well in the course. It just means you got to, now's the time to like get the ball rolling, get up and get in there. Now is the, the buzzer's going off and you're being put in the game. You got to go in and then do some stuff now. So go in there. So remember how this works. You go into Delta Math. Now it's a different view for me than it is for you. In fact, let me show you if you've forgotten. I just want to be careful about which tabs I'm showing so I don't accidentally show scores or something. So if you go in here and you go to homework, there's the link for the Delta Math right here. It's free, doesn't cost you anything. You click the link, you go in, you make a free account. It's going to put you in my class. You've got homework assignments, start them, get some scores on there, right? There's quite a few people with like 4 or 5 scores on there. Great. Many of you have no scores at all. That's not great. So just sort of work on that. And then you'll go into the Delta Math. Now, the way the Delta Math works is that you won't all have the exact same assignment. What it does is I assign types of problems. So like here's an example. You can see over here, here's an upcoming assignment. And this assignment looks huge, right? But each of these problems is only one type of problem. And some of these are pretty straightforward. They're like fractions, like calculating a percent, something like that, which is pretty basic. I mean, that's like pre-algebra level stuff. So really this big, huge assignment here, that's like pre-algebra. So it shouldn't really like take forever. Okay, so don't get overwhelmed by it. The way this works is I assign certain types of problems to be assigned, and it randomizes it for each of you. So I might have, for example, calculate this fraction or something, right? Well, each of you is going to get a slightly different fraction because it randomly chooses the fraction that you're going to get, and then you'll attempt the problem. And if you attempt the problem, in fact, let me find one. Let's go into it. What's a good one to show you on? Let's do this one. So here's what it looks like in Delta Math. Oh, by the way, if you're in Zoom, you're not going to see the visuals behind me. You just see the green wall. If you're on the YouTube stream, then you will see the visuals behind me that I'm putting up here so that it'll make more sense. You can see what I'm talking about, okay? So again, you can be in whatever place you want, but you're going to see it better on the YouTube stream. Okay, so let me kind of show you around here. There's these weird things at the front: record, score, and penalty. So basically when I set the homework problem up, the homework assignment up, I tell it how many of that problem I want you to get right before it lets you move on. The default is 5, which is a lot of times pretty good, but in a homework assignment like this where you saw that big list of things, I'm not going to make you do 5 of all of these different types of problems. That would be excessive, right? I'm having you do 1 of each of these types of problems because it's pre-algebra. Hopefully you move through it pretty quickly, but even still, if I made you do 5 of each one, that would be a lot of problems, okay? So what happens is, let's go back to where we were. You have a type of problem, and you're going to answer it. So for this one, I'm only requiring you to get 1 right. So once you get it right, it says, okay, you know how to do this, and it goes to the next type of problem. And then you're going to do that. Now, like I say, in future assignments, you might have to get 3, 4, 5 of the same type of problem right. Like when you get to factoring, you're going to have to do a few of each type of factoring because that's really just about repetition. This is a pre-algebra review, so I didn't see the point in making you do 100 pre-algebra problems, right? So what happens is it keeps track of a score up here, and that score is, and basically it's keeping track until you've hit the requirement of how many problems I want you to get right. So let's say that you had let's say we had one where, we'll keep it simple, you have to do 5 problems of a certain type. Like let me show you when we go to say factoring. Okay, well here's one. So evaluate piecewise functions. See how it says 0, 5? That's because in this one I actually want you to do 5 of that type of problem. Okay, so we go there and you come into the video. When you get one right, let me see if I can show you what this one will look like. let's see. So it wants to know f of 5. So f of 5. So this answer should be, if I'm looking at this right, this should be -3. So I submit my answer. It says, are you sure you want to submit this? Yes. And then it gives me the green check telling me that I did it correctly. Okay. And then it shows you how to do the problem, which is good because sometimes their work looks a little different than your work. And sometimes it's helpful to go, oh, I see how you're organizing it there. That's helpful. And sometimes there's multiple parts. So it can be helpful to look at their solution as well. So then I go, okay, great. Let's do the next problem. So see how I have a score of 1 here? And this is telling you the penalty is 1 off. That means when you get 1 wrong, it subtracts 1 from you. So you basically have to get to 5 points in order to move to the next topic. Well, if you get 1 right, your score goes up. If you get 1 wrong, your score goes down. So if you keep, like if you were getting every single problem wrong, you'd never finish the homework assignment. You'd just be working on it forever, and it would just keep giving you more and taking off 1 each time. So that's why it's really important that you check your answers before you submit them, right? This is a step that people like to skip because they go, well, like in most of our homework platforms, they go, well, the computer's going to tell me if I got it right or wrong. Well, in this one, you're actually penalized for a wrong answer. So make sure you understand your answer before you hit submit, and it'll save you from having to do an extra problem if you made a little mistake in there. So easy to make little mistakes. You don't want to have to do extra problems, right? And it kind of makes sense. If you're not getting the problems right, it makes sense that you would keep working on them until you understand it. Once you understand it, you can get them right. You'll get your score, and then you'll move on. So watch if I do this one wrong. I'm just going to guess the answer is not 0. And, oh, are you kidding me? I guess 0 and I got it right. That's what you're not supposed to be able to do. Let's try another one. So now you can see my score is 2. Okay, let me try this one time. It won't be right. 0, submit. Oh, it's saying you are not correct. Do you want to try it again? You get 1 more attempt. Okay, I'm going to try it again. Let's just put 0 again. Submit. Are you sure? Okay, now I got the red the red X, right? So like wrong. So I'm wrong in this case. So I lose a point towards getting that end goal of moving on to the next type of problem. So basically you want to string together successes, getting the problem correct. Okay, that means you're gonna do less problems overall, but also it means you're like checking your work so that you can move through it. Okay, so then we go to the next problem, and you can see my score went back down to 1 because I just missed a problem. I was at score 2. Now it's back down to 1 because I missed 1. Right, so see how that score goes down? Once that score hits 5, I'm going to go to the next type of problem. So just kind of be, you know, if you understand how the homework system works, you can save yourself some time by, you know, what do I say, go slow to go fast. Taking that extra time to check your work is going to save you time over having to do extra problems. It's much faster to check your work than it is to do a whole new problem. Okay, so just kind of check that. And then it will just naturally move you through all the topics as you're getting them right. And then at some point you'll have the assignment finished. And the grade book looks different for me than it does for you, but you should be able to go through and look at it and see these are my scores that I got on these different assignments. So some of you, if you go in there right now, you have like 4 or 5 assignments that you know you got your hundreds on it. So and also what that means is you never really miss out on points until it's past due. But if you just keep trying, you can just keep getting those scores up, which means I have students who get 100% on the homework because they work on every homework assignment until they get it to 100, and then their homework grade is 100%. It's pretty good. You're probably going to do pretty well in the class if you're operating at 100%. So that's what that looks like. Make sure you read the directions. Sometimes I have students, especially when we get to graphing. Let me see if I can find one. I don't know if we have one where we actually have to do the graph. So there's like directions here. A lot of times people just naturally like skip directions, but I would read them because if you have to email me, you know, it's going to be a while before you can get to it. So just read, click and drag to make a line, click the line to delete it, click on an endpoint of a line to change it. So if I want to make a line, I click. Why isn't it letting me click here? Grab the phone. what's going on? Oh, click and drag. Is that what I'm not doing? Click and, there we go. I was clicking but not dragging. So click and drag. So you're going to go, I want it here and here. And then if you want to change those endpoints, you can click on the ends to change the type of endpoint that it is. Okay, so it tells you that in those directions. So make sure that you're reading those. And then you can, if you click on it to just delete it, then you're done. Okay, well, you're done with that line. You can do a new line. You've finished out that old line. You've erased it. You can put a new one in there. So that's how you do the graphing. There's almost always directions on there that are like, a lot of times I'll get a question. Someone says, I don't know how to do the endpoints. And then when I look, it says, click on an endpoint to change it. So you just try to read the directions a little bit and you should be good. Also, careful for the watch help videos. A lot of people they make it very far in the course without realizing there's help videos available to you. So if you click it, a video pops up right here, and they're going to do a very similar problem. So you watch the video, and then you go, okay, I think I understand now, and then you hide the video, and then you do the problem that you're working on. Okay, so there's videos for almost all of the problems that you run across. So if you ever get stuck, watch the video. Right? There's the videos that I've posted for you in Canvas, and then there's the videos that are embedded right here, literally right in the homework problem. So they're highly relevant to that problem because Delta Math put them literally on that problem, right? So you can get some help with that way. But you know how it is with websites, we just learn to ignore certain things on a website. The ads down the right side of a page, we don't even see it. The writing at the bottom that's like fine print, we ignore it. We just go for what we want. But while you're getting comfortable with the homework, make sure you're looking at everything and kind of figuring out how it works. It's going to be to your advantage to understand how Delta Math works going forward. Okay, so watch the videos, know how the scores work, play around with the graphing till it makes sense with you, until you can go through and make all those work. It's just kind of clicking on stuff. Whoops, clicking on things. Okay, so there's that. And then eventually you're going to finish the assignment. It's going to say, congrats, you have 100% completion on this assignment, and that's great. That means that's good. Basically, you want lots of green checks. You don't want a lot of red crosses, red X's. Try to get 100% completion, and you should be good to go. Now, I have this set so you can work on it after the due date, but there is a 50% penalty for points. So you don't want that because 50% is way, way better than 0, but it's way, way worse than 100, obviously, right? So, stuff happens, like legitimate stuff happens where people didn't get something done on time. Just try not to let it happen too much because too many of those 50s will start dragging your grade down. And if let's say you did like 80% of the homework, but then you had to go, your kid got sick at school and you had to go pick up your kid, and that ate up the time you meant to spend on the rest of that homework for the rest of the day, and so you didn't get it in on time. You're only going to get penalized for the part you didn't do. You still get your credit for the part that you did do, so there's a little bit of a penalty. But, it's better to get 50% on 10% of the assignment than 50% on 100% of the assignment, right? So just try to do as much as you can. Try to legitimately do the homework and work through it, and you should be fine, right? There is a bunch of stuff here at the beginning. I do have videos posted because there's just no way with this class that I'm going to be able to cover all of the algebra that you need during our meetings. So what I need is, or what you need to do is watch the videos, try to work your way through it. If you have problems, come to my office hours. If you have problems, go to the tutoring center. You can get remote tutoring right now. You don't even have to physically go there. You can Zoom in with them. They have a lot more availability hours than I do. I have 5 office hours a week. The tutoring center is open many, many hours a day, so they're helpful in that regards. To moving forward and getting this done, and like I said, you should at least have some stuff done by Thursday. It's not all due for like another week, but you should get started on it so that I can make the case that you're progressing in the class and that I didn't need to drop you. Okay. But if you're if you're in a situation where you haven't done homework, not really even if you're showing up but haven't really done any homework, the deans are going to say, why didn't you drop this person? So just be aware of that, right? Okay. Let's see. Let me collect my thoughts here. Oh. Got the book. Where's the camera? Got the book. So for those of you who don't know what it looks like yet, I've got the book. You don't necessarily need to have a physical copy of the book, although if you can find an old version online, not a bad idea. What you are going to end up having to purchase is the license to do the online homework, and that's what I'm still kind of setting up. So give me another week, and then I'd hope to have it all done by this week, but I've hit another snag. But I'm working with the publisher, and they're helping me get it figured out. So by next week, I should have all the information, I hope, for what you need to purchase, and then... But don't sweat it. We're not gonna use that book for like 2 months anyways. So that's all gonna work itself out. I mean, by me working on it, it's gonna work. Okay, let's see. Okay, yeah, and that's actually a good point. I think we're to the point where I can see if anyone's missing. So I'm only calling out the names of people that I do not have as being here. So if I call your name, that means I have you listed as absent. So then let me know. So Jackie A, Alicio Bonilla, Victor Casillas, Carly Davies, Maritza Delgado, Whitney Harchenko. Oh, so, okay. Oh, sorry, and I'll try to just use the first letter of last name. Sorry about that. No, it's okay. Whitney H. That person dropped. Rochelle P. Hi, can you hear me? This is Whitney. Oh, okay. Let's see. Okay, thank you, Whitney. Gotcha. And then let's see. So no Crystal. Rochelle P. Brianna R. Hi, I'm here. That's Brianna? Okay, gotcha. Yeah, Brianna. Okay, I gotcha. Thank you. Jennifer R. And this person dropped. So just those people I mentioned. If I called your name, please let me know. Otherwise, later this week, I have to start doing drops for stuff. Yes, I got you. Thanks, Elizabeth. Okay, great. So I think we're good with that. So I probably won't be as strict with taking roll going forward, but I highly, well, I may be. We have had issues with, that's right, we've had issues with attendance. So I probably will keep taking roll, and that will work itself into the grade. So please do keep attending. But this is the week where I have to actually go through and drop people. Okay, with that said, let's see. So the thing is, when we meet, we're very limited in time. And so with the algebra, I mean, theoretically, you've all seen the algebra before. I know that in practice, that isn't necessarily true. But theoretically, the algebra is kind of at least a large portion of it review. Don't panic if you feel like it's not review for you. That's okay. It's just going to be a little bit, it's going to take a little bit, it's a bigger challenge. It's going to be a little bit more work for you because we move through this course, the algebra, quickly. We take kind of the bigger topics from our intermediate algebra course. We take the bigger, kind of harder topics and we cover them in just half the time. So it's already moving quickly, and then we only meet for 90 minutes a week. So it is not possible for me to cover all of these topics and teach you all of these things in 90 minutes on Mondays, right? It's an online course, so that's why the videos are available to you. The videos in Canvas, the videos that are in the Delta Math problems. And then please, if you feel like you need help, come to my office hours. I'm not getting a ton of students in office hours this semester, and it's still kind of early. but that means there's room for you, plenty of room for you if you want to come ask me questions. And then there's always the tutoring center. Okay, so you're going to be learning a bunch of algebra in the first 2 months. The feedback that I get from the fellow teachers who have taught this, which is students usually find the second half of the semester easier than the first. I haven't taught this course recently, or I haven't taught the course at all, so I can't vouch for that, but that seemed to be the consensus. So do realize it sounds like the algebra involved in the second half of the semester is not as bad, although everything second semester is like word problems, because that's what you're going to be doing in real life. You're essentially doing a word problem in real life when you're doing this on the job, right? As a nurse or an EMT or whatever it is that you're doing, no one's going to come to you with a piece of paper and says, finish this equation for me. That's not how it works, right? You have to figure out a dosage, or you have to figure out, how much to dilute a thing or whatever. That's the kind of problems we're going to work on. They're all word problems, but they're also literally like what many of you are going to need to do in the future. So that's kind of where we're headed. So I'm kind of picking and choosing what to cover. It's a little bit of a guess because, like, if we're in a classroom, I can get pretty good feedback on the questions that people have. But you're all working by yourself in your homes, working on stuff, so it's hard for me to know the questions that people really need to see. And just because people haven't done a homework assignment doesn't mean they need to see homework problems on it. So please don't be afraid to send me a homework problem. Like, be specific about what it is. Like, screenshots, good. Let's see. So, okay. So, person who's listed. So, someone just came in saying, sorry, I was late. I couldn't log in. So, you're just listed as iPhone. If I could get a name, then I can mark you on the roll and make sure that I don't drop you. So, whoever just came in and left that message, if you could let me know your name. That would be great. So letting me know what problems you need to see is probably a really good idea because okay, I got you, Maritza, thanks. Letting me know what problems you want to see is a good idea because otherwise I'm guessing. But if students have asked me about a particular problem, then I go, ooh, I'm going to make sure I talk about that one because the reality is if one of you asks me a question, 90% of the time, you're not the only one with that question. 90% of the time, there's at least 3, 4, 5, maybe half the class has that same question. So that's kind of a good way to run things. Please do not be afraid to send me a question. I can't guarantee I'll be able to cover it, but if you send me a question and say, I was working on this, I don't quite get what I'm doing wrong, and then let me know, then I can prepare it. Like, it'll be even nicer because I'll have it prepared to talk about. I'll have the problem open in a tab, and I'll have already thought about what I want to say about it and how I want to explain it and all that kind of stuff, and then I can walk you through it. But we do not have time to do that for all of the things, right? It just isn't going to work that way. Oh, great question. So question about, are we sending via email? What do you want in the subject line? So there's 2 ways to do this. You can just say, like, homework problem. Please make sure to tell me which class you're in, and even throw in Mondays because I do have 2 of these Math for Meds classes, and they're going to be on different schedules, and one's on ground and one's in class, so they're going to be very different. So if you just say, oh, I'm in your Math 35 Monday class, and then see how when we do an assignment, there's kind of 2 ways you can do this, which is helpful. One is if you send me a screenshot of the problem, then I can find exactly what problem that you want to see. Okay, and then also if you do this, like, a lot of times students will just take this part. That's the type of problem you're working on, and then they'll send me that. They'll say, oh, I'm working on percent more or less multiplier level 1 and I'm stuck. Can you help me, or can you go over that or something? And then I'll pull a problem up like this. It won't exactly match the one that you're doing on the homework. It'll have different numbers in it. Like, it might say 50% instead of 25% right here or something, but it's basically the same problem. And then I'll go over that. So either screenshot it for me and send it to me, or send me this information, and then I can like pinpoint exactly what your question is. What some students will do is say, I'm having trouble on the factoring homework. Where is the factoring homework? Here we go. Like for instance, right here, we have 2 homeworks on factoring, and there's what, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 different topics under factoring homework problems. So if you just say, oh, I'm having trouble with the factoring, I still have no idea. I mean, that's an entire chapter in algebra is factoring. So please, if you're going to contact me, be specific. Either send me a screen grab of the problem or give me that title that's in it where you say, oh, this is difference of squares with binomials. Then I know exactly what you're asking about. So more information is good. I'm still like 90% of the emails I'm getting, I'm responding with like, well, here's some tips that I think may be helpful, but I'm still not really sure what the person's question is, because they were sort of not, they gave me some information, but not a lot, like not enough to really know what the question is. So if you give me this information, I can know exactly what you're asking me, and I can go in and help you. Okay? And then we can talk about it in class. And it's really good for me too, because then I know if I'm getting certain questions, then I know those are the ones I should talk about during class. Otherwise, if I pick a topic to talk about, you might all have already like learned how to do it, and you don't really need to see that problem. So it's helpful in that way. Okay. So there's that. So there's the factoring stuff, which we'll get to. Now the factoring homework's not due for a couple weeks. We do have some homework due, a week from now. And some of this, like I say, some of this is pre-algebra, so hopefully you move through it pretty quickly. Some of it is not. So this rationals homework is a little in-depth, and the rational equations homework is a little bit in-depth. Those take a little bit of work to go through and do. And actually, the rational equations, honestly, watching the videos that are both in Canvas and part of the problem here where they say watch help video, those are kind of the best way to learn that. Like that's a topic where in class all I'd be doing is repeating what I've already done in a video, so it's not super helpful. What I kind of wanted to look at today was a few things that I know students struggle with, which is functions and doing some of this function work. And I know students had trouble with the compound inequalities here. So you want to make sure you recognize these symbols over here and understand what they mean, because what I saw was students were emailing me and they were like, I think I'm getting it right, but it's telling me I'm getting it wrong, but it wasn't right. Like it was they had the right idea, but they weren't quite finishing the problem off. So what you can always do too, if you get one wrong, like remember, let's get one wrong here. I'm pretty sure that's going to be wrong. Yes. No, let's get it wrong again. If you get one wrong, remember they show you how to do it. So you want to go through and see like, oh, here's how they did it. Here's how they set up the problem. What am I doing wrong? And then so notice how it had 2 inputs. It had the answer for me, and then it also had a graph that I needed to draw. Remember how we talked about these arrows a little bit with the open-ended and close-ended? Close-ended means include the endpoint. Open-ended does not. So for instance, this 12 would mean everything up to 12 and including 12. This circle that's on the 4, that means everything going up to 4 but not 4. So like 3.999999999 would be included on this line, but 4 would not, because that's where the open circle is. And you get these different ends by just clicking that endpoint. It changes that type of line that it is. But what I was like the other day, I answered an email where a student was getting these right, x less than 4, 12 greater than or equal to x, but she wasn't putting the or in there. And then that was the mistake. And then, so then I said, oh, I think this is what's going on. And then it was all taken care of. So I think it was, at least. So you just want to really watch those answers and try to figure out, like, what am I doing differently than what they're doing if you're getting it wrong? Okay. Let's do next problem. So, and let's just see if, let's double check. So we've got that. Yeah, so see how when I click it, it changes the type of circle on the end? So that's what you want to do. Just click the thing. And it says click line to delete, click close circle to change to open circle. So you just click them to change it to the different type of circle. And then here's your or. So, you could put in your, like, x greater than or equal to 3 or x less than or equal to 5. I mean, I'm just making up this answer, but see how it puts the or in there? I believe you can type the or you can hit the or button. But you have to do both, because otherwise, if you leave that out, it's not clear. In mathematics, the words and or are part of the fundamental logic that all of mathematics is built on. Well, I should say most of mathematics is built on. So that or and the and make a big deal. So we can't just put like a comma there, right? If you did this, you're like 95% of the way there, just not quite there. You got to put that or in there. And then you're good, and then you know how to do it, and you can say, oh, great, I understand how to do this now, and then you can move on, right? This circle with a line through it, they're really pushing that into like algebra and lower levels of algebra, where I kind of feel like we should be waiting to put that in like higher levels of math. I don't know that we need that in algebra. It just confuses people. The more notation we stick into algebra, is difficult for people. So just realize that means no solution. It's technically the empty set, so your solution set is empty, meaning there's no solution, right? It's just a fancy way of saying no solution. So that's what that, excuse me, that means no solution. And then this means all the real numbers. Okay, so that's what those are. Yep, and I got a question about piecewise functions, which is actually the number one thing I wanted to talk about today. So that's great. So see how people are saying, oh, I'm struggling with graphing piecewise functions. If you have time to go over that. Yeah, students always struggle with that. So I'm glad you brought that up, because that's kind of case in point. I kind of suspect that's where people are having trouble, and then a student brought it up. So now I know for sure, oh, that's where students are struggling. So let me go over that. Okay, so people are pretty good with the compound inequalities. It's more like knowing how to answer the question that I think is usually the concern. And so we just went over that. So hopefully you be good with that. Yeah, so I want to talk about functions, and especially piecewise functions with okay, and we got plenty of time to go over that, so we should be good. So we'll start off with some easy evaluating functions. Okay, so let's just, and I definitely will get to piecewise functions. So evaluate, just as a fancy term for make the substitution and simplify. All it means when we see this, where it says f of x, that means that the function's named f, and the variable we're using is x. Everything in this class is what they call univariate, or one variable. So that's nice. It means we're usually just going to be dealing with one variable at a time, so it shouldn't get too confusing. So the function is named f. The variable is x, and here's the rule for how you figure out what that function is. In other words, a function changes something into something else. Like, a lot of times in algebra books, they make it like, so the function is like a little machine that you put something into it, and it does a bunch of work, and something else comes out, like an old Dr. Seuss comic or something, where there's all these like pistons and belts and everything moving, and then all of a sudden it gets changed into some different thing. That's what a function does, is you put something into it, it has a rule that it follows, it changes that thing into something else. So what does f of 0 mean? Well, notice how over here the f has the variable x, but over here f next to it is the number 0. Well, what that's telling us is that the x has become a 0. Okay, so we have to say, well, what happens to this function when my x is 0? That's literally what you're asking. What is the output of this function if I put 0 into the function, right? So we could just go, okay, so it's 5x plus 1, f of 0. Okay, so let's go. F of x equals 5x plus 1 when, and we want to find f of 0. This is a typesetting software that works live, so it's just, it's hard. Like if you're using a Word document or something, it takes forever to try to get the math formatted. This is a programming, sort of a weak programming language for typesetting math. So, but it makes the math look better than if I was trying to use Word or something like that. So what this means is, so let's see if I can make this a little bigger maybe. A little bit. Whenever I switch tabs, I always got to keep adjusting the screen. So what this means is we would go, okay, well, f of 0 means that everywhere there's an x, I'm going to put a 0. So it's going to be 5. Now that thing that was an x has now become a 0 plus 1. Well, what's 5 times 0 plus 1? Well, that's just 1. So see, our input, which we oftentimes will call the x value going into this function, is 0. And the y value, the output, the thing coming out, is a 1. So then I go back over here and I say, I think this is 1. If I didn't screw this up, it should be 1. There we go. I got it right. And you can see, like, look, their work looks just like mine. They changed the x, substituted it for 0, simplified. Here we go. So evaluate's real easy. It just means turn the variable into this number over here. Okay, and then they get a little more complicated where like you might have an exponent or something. It's the same idea. You're just going to, everywhere there's an x, you're going to put a -1 in there, and then you're going to simplify your work. So not bad. Okay, now evaluate functions from a graph. Now this is the same mathematics, but from a different perspective. We just did evaluating from a algebraic perspective. We now want to do it from a graphical perspective. And this is one of those cases where, like, if you understand functions, this isn't bad. If you're just memorizing things, which is a technique a lot of people use to learn math, you're going to struggle, especially with the graphing. Like, that's a lot of times what I find is when people are just trying to memorize things, they really struggle with graphs because you can't memorize everything in a graph, right? You just kind of have to learn it because every graph's a little different. So they say here, find the value of f of 7. So what does this mean again? F of 7, well, that means we have this function f. This function right here, that's a picture version of the graph. So we were just looking a moment ago for a different function. We were looking at an algebraic version of writing it. Now we're looking at an image, a picture version of the graph, what it looks like. Okay, well, f of 7, what did that mean? Oh, that meant that my x was 7, right? Well, x's, those happen along the x-axis. Here it's even labeled, right here, the x-axis. Oh, so I'm concerned about when x is 7, that's right here, right between the 6 and the 8, that's my 7. Okay, if my x is 7, then what's my y value? Well, we go up to the function and say, well, the y value, when x is 7, my y value is 6. See that? So you go in and say the answer is 6, hit submit, and we're good to go. See how that's basically what I was just showing you. They went up from 7 and figured out that that point here has a height of 6. Okay, so that's all you're doing is it's the same x and y argument that we did algebraically, but now you're getting it from a picture. Okay. Then we get into piecewise functions. That's where people get confused. Like most of what I've said so far, when I explain it, people go, oh, okay, I pretty much get it. Sometimes the graphic ones throw people a little bit, but now we start dealing with piecewise functions and people get confused. Now, the only thing you need to know about a piecewise function is it's sort of numerous functions put together to make a single function. So it's the kind of like a Frankenstein function where we've taken different functions from other places and we've just sort of sewn them all together to create one new function. And sometimes they look really smooth and clean. Sometimes they look really horrible and ugly. It doesn't really matter. It's just a series of functions. So for instance, I think it was the other class this morning where there was a question, a homework question we were working on that was about like utility bills, utility rates. So this is a good example. I don't know how many of you have ever paid a water bill or an electricity bill, but generally the way it works is that there's tiers. So that is your first, let's just say electricity, your first, whatever, 1,000 kilowatts, you pay a certain price. But they kind of want to punish people who are excessive. This is especially the case with water bills. As you use more and more water, the amount of money you spend doesn't just go up linearly. It gets way more expensive. So once you get into tier 3 for your water bill, you're spending a lot of money, right? Because they're like, you're using like an excessive amount of water. We're going to charge you an excessive amount of money for it. So it could be that for your water bill, when you're, you might be paying, 25 cents. Let's see, for the water bill. I forget what unit they use for the water bill, if it's thousands of gallons or whatever. So let's go with electricity. So X equals, we'll just say it equals, I'm making these numbers up because I can't remember what prices are for stuff. But we'll say X equals 25 cents when, see, 0 is less than X is less than, say, 50. Whoops, it shouldn't be X equals, it should be Y. So see, we have this line here, but the line doesn't go on forever. It goes to a point and it stops. So your electric bill may say you're going to pay 25% per kilowatt hour up to you've used the first 25 hours. That's cheaper. And then they might say, once you go beyond that, we're going to charge a little bit more because we really don't want you to use too much energy. So then your cost might be Y equals 35 from 50 is less than or equal to X is less than 100. So now we have this line right here. See how these don't touch or kind of make sense together in any way? That's okay. They're still a legitimate graph. Okay. So if this is a graph of our price, we go, okay, as long as I use less than 50, I'm paying this price. But once I go past that, any extra kilowatts I use, I'm paying more for. I'm paying an extra 10 cents per kilowatt hour. I'm doing this. And then a lot of times, like with water, it's really bad. If you go into tier 3 for water, it's like they really start to gouge you. So it might be like Y equals, 60, but only for 100 less than or equal to X. And then it just goes on forever. Like you'll pay that tier 3 price no matter how much you do. So see how what we really have here is like 3 separate graphs? It's like 3 separate problems. They don't, like people really get bothered when they don't connect. These are what in mathematics we call discontinuities. There's nothing wrong with discontinuities. Sometimes they make things easier, sometimes they make them harder. But for the algebra we're doing, we don't really care if these things touch each other or not. We just want to realize we've essentially taken 3 separate functions and we've just kind of smashed the parts together that we wanted, and we've created a new function. And I can ask this function a question just like we did earlier. I can say, well, what would the function value be? What would f of 75 be? Now it doesn't know what f is. I'm just sort of calling it this. Well, remember that's my input. So I'd go, where's 75 on here? Oh, it's between 50 and 100. So my y value is this one that is 35. Okay, so it's really the same thing that we just did with that graph. We were looking at the graph. We had an x value and we found a y value. We're doing it here, but people really get thrown by these piecewise functions because they're like, there's too much. I think it's just too much going on, and the notation is weird. That's one of the big things about math is people get confused by the notation. Notation is just a placeholder for something else you're supposed to be understanding. Sometimes people look at a notation and they're thinking that like the notation's going to give them the answer. The notation's like a shorthand to help you remember the thing that you're doing. So we've really smashed 3 different functions together. That's what a piecewise function is. It's just we've taken other stuff and put it together. Piecewise functions could be all sorts of stuff. So you can have y equals x, but that only goes from -2 less than x less than 2. You know, and then we can have y equals x squared. Let's make it -1. And that's going to go from 2 less than x less than 5. And then we can have, you know, y equals square root of x, but only for 5 less than x. So see, we have here, it's a little more complicated, but it's just 3 functions that I've put together, and then you just have to decide which one are we talking about. So how do I know which function I'm supposed to use? What is your x value? Is your x value between -2 and 2? Then you use this top rule. Is it between 2 and 5? Then you use this middle rule. Is it greater than 5? Then you're looking at this blue one over here. Okay, so people get overwhelmed because they're looking at 3 functions at once. You're really not. You're just looking at one function with 3 parts, which still can be overwhelming. But always ask yourself, what is the x value that I'm looking at in order to determine the y value that I care about? So let's go back over to here for delta math. So evaluate piecewise functions graphically. Okay, so let's look. Evaluate this function graphically, and they want to know about f of -4. So remember, that means that -4 is my x value. So on the x-axis, I'm going to find -4. That's right here. And I'm going to go up to the function value and go, oh, 6. Okay, so then my y value here is 6 at -4. So I'll say 6. And we got that right. See how they use that line to go from, you find -4 on the x-axis, and then you just go straight to find the y value for that point of the graph. And people go, yeah, but what about this thing over here? This thing over here didn't matter to us because we only cared about -4. If they had asked us about f of 5, then we'd care about what's going on over here. But they didn't. They asked us about -4, so we care about this one over here. Let's do another one. Evaluate the function graphically. So remember, if there's a hole in it, it means the values are approaching that point, but it's like we poked a little hole right there. So it's not, doesn't exist right there. And then the function value actually exists right here. So what they say, what's f of 5? So that's right here. We go f of 5. Well, it looks like my function value is 2, right? It's not 3 because that 3 is indicating we have a hole there, right? A hole is an absence of a thing. It's not a point. It's an absence of a point. So here we've got 2. So we go to x equals 5, go up. Our function value is 2. So I'll put 2 in there and hit submit. And we got it. Let's look at another one. Okay, so here, I sometimes, like, I highly encourage you to read directions. I sometimes have students that will try to move ahead without reading the direction. And then here's the thing. If you don't read directions, you're going to end up doing the wrong thing, right? It's not surprising. So if we go to, like, students will look at this and immediately go, oh, like that last one, the answer was the dot, not the hole. So I better put 5. But they're not asking us about x equals -1 or x equals 1. They're asking about x equals 3 here. So you have to make sure you're looking at the right x value. So then I'll go over to x equals 3 and say, oh, it looks like the y value is 6. Okay, so I put in a 6, submit answer. There we go. We got it. See what this one is. Ooh, this one's starting to get a little more complicated. We got a dot here and then like 2 lines that are connected. Let's see, f of 9. Okay, so if I go over here, f of 9. Well, there's no function over here. What am I supposed to do? There's no function. That is what we call in mathematics undefined. So I think they want me to write undefined here if I remember right. Oh, there's even an undefined button. I didn't even see that right away. See undefined? And we got it right. So you can write undefined, but also there's a button for it. What does that mean? That means this function isn't, it doesn't make sense for the problem that we're working on, right? It means we don't, that's the thing that doesn't make sense. You might go, well, what does that mean it doesn't make sense? Well, you know, sometimes things don't make sense if you do them in a certain way. Like say maybe you're a shoe company and you're buying shoes and you have prices based on the number of shoes that you're buying. Well, generally shoes are bought in pairs. So it could be that maybe you're dealing with a manufacturer, a vendor, where you have to buy an even number of pairs. So you could say, well, what's it going to cost if I buy 500 shoes? And they'd go, well, that's 250 pairs. Here's what it's going to cost you. What if you said, how much is it going to cost for me to buy 197 shoes? You go, well, we only sell them by the pair, so you can't buy 197 shoes. You could buy 198 or you could buy 196, but we won't sell you 197 because then we have some shoe left that we're never going to be able to sell. So you gotta buy them in a pair. Okay, so undefined just means it doesn't make sense for that function, right? That function is not defined to work in that particular way. All right. So in this case, f of 9 is undefined. Always keep that as an option. What about this one? F of 2. So our x value is 2. So I go to 2 on my x-axis, and I'm saying, well, where's the function? There's a hole right here, so that means that my point's not right there, and it's not below it, and it's not above it. I don't know where it is. So it looks like it's undefined. Yep, it's undefined, right? So see, they keep putting that line there. It's really just a matter of go to that point on the x-axis. Think of a green dashed line going through. Wherever you hit your function, that's your y value. But you don't always have one because, like in this case, it's still undefined, even though it kind of looks like it might be. It's undefined. Okay, and so see, here's a good example. It says, hey, series complete. You have met the required number of problems for this section. To move on to the next section, press the back button. You may continue working for extra practice, but further correct or incorrect answers will not add or subtract from your overall grade. So you can keep practicing it, but once I've completed it, it's saying I'm good to go. So I say, okay, and now I'm going to go back, and now I can work on another part. Okay, so see how it's got my 5 out of 5 over here? I think this is what it looks like for you all as well. I have other screens where it's got like a teacher version and a student version where they're different. Okay, let's see. Graphing piecewise function. I forget the difference between these two right here. We'll take a look at both of them. Okay, so here's how we write a piecewise function. So far, I've shown you piecewise functions graphically. That is where we saw kind of this Frankenstein idea of different pieces that were just sort of smashed together on the screen. But what is this I'm looking at now? I don't even, what is going on here? Well, remember how we normally write a function? So we had one back here, right? Let me get rid of this extra work. So we normally write a function right here, which is we give the name of the function, the variable, and then we give the rule that says this is what you do with the function. Anything you put into this function, you're going to multiply it by 5, and then you're going to add 1. That's the rule. Like whatever, you can put all sorts of stuff in there, put in 6. Okay, multiply it by 5 to get 30, add 1, you get 31. Okay, what if I put 10 in there? Multiply it by 5 to get 50, add 1, you get 51, right? So this rule always gets followed. Well, what this notation over here means is that we have 2 rules. Well, you can't always follow every rule, right? We can't do both of these. So you have to do one or the other. How do I know when I'm supposed to use the top rule and when I'm supposed to use the bottom rule? And the answer is you look over here to the right. So it tells you. When x equals 4, you use the bottom rule. When x is not equal to 4, you use the top rule. So in this case, I go, okay, well, it looks to me like x equals 4. And this says that when x equals 4, I'm supposed to use the bottom rule. So it looks like my answer is 4. And there we go, right? So see how they put it in green? That's the key here. X is 4, so I use the bottom rule. But then it just so happens that 4 is also the rule, right? Maybe they made it a little confusing with too many 4s. Let's try another one. And let me read this comment. Okay, yeah, so we'll go over the, we'll spend some time on all that because I know students by and large get confused by the piecewise. So we'll kind of go over it a few times so people can start to put it together. Okay, so here the numbers don't match up perfectly. So find f of -2. Okay, so my x is -2. So I go up here. Oh, this says when x equals -2, I use the second rule, which in this case is 4 again. 4, submit the answer, and we got it. Okay, so you find the x value you care about. You find that on the, here they graphed it. We didn't start off with a graph, but this is the graphical version of that thing. And I know some of you are asking, well, how do we graph it then? We will get to that for sure. Let's try one more, see what this one looks like. Here we go. They're making it a little bit more complicated here. Oh, graph, which one is this? Graph the following function on the axis provided. Okay. Yeah, okay, let's do a few of these. Okay, so what do we have here? We have a, whoops, that's not what I wanted. Did I click the wrong thing? Graphing piecewise functions. A couple people have asked about this. So let's see, let's just try to understand our function here. Okay, so we have two rules. Sometimes our output is equal to 2. Sometimes it's -2x plus 3. And it's for when our x's are between -3 and 0, and also when our values are between 0 and 3. Okay, so what does that mean? Well, let's go over to Desmos. Oh, by the way, this tool I've been using to graph, this is a free tool. This is just a website, Desmos, D-E-S-M-O-S. You do not have to use an account or anything like that to use Desmos. So if you wished that you had better graphing utility at home, you can just use Desmos for free, right? There's nothing wrong with using it. Come in here, learn how to use it. It's pretty easy to use. That's why it's gotten very popular. And you can use it as well. So let's see. Let's try to break this down. So I have two functions here that we're sort of, it's that Frankenstein idea. We're putting these together, but we have to do it in the right way. So two functions. One is y equals 2. That's one of my functions, which is a horizontal line, right? That means the output is always 2. Okay. All right. And then we have -2x plus 3. Let's look at that one. So here I've got my two functions graphed. And when I give a test and I make students graph a piecewise function, this is about what half the class gives me. Is they graph the y equals 2 all the way across, and they graph the -2x plus 3 all the way across, and they say, there's your piecewise function, except remember, this isn't a function. These two things together cannot make a function because they don't pass the vertical line test. Remember the vertical line test? You pass a vertical line over it, and if you ever hit your graph more than once at the same time, then it's not a function. Look, right here, I'm hitting it here, and I'm hitting it down here. So those can't both be part of the function. We must have to break it up. Well, it's because what we've done so far is not complete. I'm breaking a rule. This says that the function only follows the rule that y equals 2 when x is between -3 and 0. Well, that's from, right? Let's see if I can get, here's x equals -3, and here's 0. So that green line should only be existing over this region right here. So then I can go up and I can restrict it and say -3 is less than x is less than 0. See how it just shortened now? It's only for the x's between -3 and 0 does this function exist. So you're using the graphing stuff that you've already learned about graphing lines and stuff like that, but now we're doing it, we're restricting it to a specific area where x is between -3 and 0. Okay. All right, what about this other line? We still fail the vertical line test because look right here, I'm hitting both of these at the same time. Well, they can't be the same function then. Well, my second rule, -2x plus 3, that only holds for when x is between 0 and 3. Well, that's kind of off screen there. That's this region right here. So this purple line should only be existing over this part of the x-axis. So then I restrict it as well. And now we get this, and that is what our piecewise function looks like. We've got a little stretch here where it's a horizontal line, and then we've got this stretch here where it's a slanted line. Okay, so that's what that piecewise function looks like. So the key is to graph we graph both of these functions that we're given, but we only do it over the corresponding x values. We don't do it for the whole range. Okay, so let's see. What this should look like then is that, let's see, click and drag to make a line, and we said that should be at 2 from -3 to 0. So that one should look like that, except notice how these are not less than or equal to's, they're less than. So that means these should be open circles. So I should open those. So see how I'm clicking them to open them? Oops, that's not what okay. If these were less than or equal to signs, then we would put the solid dots in there. But they're not. Okay, now we want this line, -2x plus 3, that goes from 0 to 3. So we said that's from here. So let's see, that's going to go from 3. And it's going to go down, what is it, down to over 1, and we're going to, let's see, so down to over 1, that should go to there. But again, we want the hollow dots. So see how this function only exists from -3 to 0, which is what it says right here, -3 to 0. And this one only exists from 0 to 3, which is what it says right here, 0 to 3. And then I submit the answer. Yes, and I got it right. That's what it went with. So that looks good. And they kind of show you, here's the right one, here's yours. In this case, they match up, meaning I got it right. Okay, this one's a little bit more complicated because we don't have any horizontal line. Horizontal lines throw people sometimes. Okay, graph the following function on the axis provided. Okay, so I've got the line 2x plus 10, but that's only for when x is between -6 and -2. And then I've got the function -x, but that's only for when x is between -2 and 5. So let me see, what would this look like if I was going to graph this? So 2x plus 10 would go, I don't think it's going to let me shorten this. I have to remember how to do it for this one. Let's see, so we want a slope of 2. So for -6. That's not right. Okay, so let's see. Let me write this down. Well, let's go ahead and do this over here. So f of x equals 2x plus 10. Oops. F of x equals 2x plus 10. So here's one way that can be helpful to figure this out. I know I'm concerned about the region over which we go from -6 to -2, right? So why don't we just figure the point of the line at -6 and figure the point on the line when x equals -2, plot those 2 points, and draw a line through it. Yeah, great idea, Chris, right? Let's do it that way. So f of negative 6. Oops, I keep clicking that. So let's go f of negative 6. And that equals, so that's 2 times. See how we're back to the evaluating we did at the beginning? All these tools build on each other, so you really kind of have to know them all. Negative 6 plus 10 equals, so that's going to be what? Negative 12 plus 10 is going to be negative 2. So what that tells me is that the point we're after is an x value of negative 6 and a y value of negative 2. So I'm going to come back here to delta math, and I'm going to go to negative 6, negative 2, and that's where I'm going to start my line. Oh, it's not showing up on screen. I got to keep changing it every time. Negative 6, negative 2, and then we're going to go up to some other point that we don't know yet. I'm probably going to have to erase that. I'm sure that's wrong. Okay, now we want to know at negative 2. So I'm going to come back here and figure out f of negative 2 equals, so that's 2 times, now I'm changing my x to a negative 2, even though I wrote 3, negative 2, plus 10. Ooh, I got a couple typos here. Hold on. I guess my hands were in the wrong space here. Lined them up wrong. So 2 times negative 2 plus, now I'm thinking I messed it up. Nope, that's right. So that should be 6 equals 6. So what that tells me is when my x is negative 2, my y is positive 6. So then we go back. So we want what? We want negative 6, 2 and negative 2, 6. Okay, that's a little confusing. So we go negative, wait, was it negative 6, 2 or negative 6, negative 2? Yeah, negative 6, negative 2. So we started, and then we want to go to negative 2, 6. So that's going to be negative 2, 6 is going to be up here. Okay, so let's get rid of that line. Go negative 6, negative 2, and then go up to negative 2, 6. And we want, these are not or equal to, so we want these to be hollow endpoints because we're not including the endpoints. So that I believe, well, if I haven't messed this up, that's what the first part should look like. Okay, what about this piece? What about the negative x? Negative x is a line that looks like this. It just goes through and does this. Right, that's the line y equals negative x. But we only want that line between negative 2 and negative 5. So, or negative 2 and positive 5. So that means we're going to go from here to there. And we want what? We want, this is a less than sign, so we want this to be hollow. But look at this. We're seeing this for the first time. The less than or equal to, that means include the endpoint. The endpoint is valid for this, this function. So we leave that point solid right there because of this less than or equal to right here. That's indicating this is solid. So if they're just, if there's no equal to part of the inequality, you leave it open-ended and a dot, a hollow dot. If it's or equal to, you make it a solid dot. All right, let's see if I managed to screw this up somehow. Nope, I got it. Okay, good. All right, so that's what that graph looks like when you go through and do that. Okay, so I know it takes a little bit of practice, but the key is just remember, you're just looking at separate functions, but you're only looking at a specific portion at a time. They should not be overlapping, where you have like a line over a parabola or something like that. It should be like these where they don't overlap each other. And all it is it's just different stages of the same function. Let's see what this one looks like. Ah, that's like the other one. Yeah, it's like the other ones we did. So let's go back. Okay, which one was this? Evaluate functions. Okay, this is just a more evaluate. So you just plug the value into the variable and then see what you can do from there. Okay, so just simplify it. So if I stick 10 in here, remember your order of operations. People get confused about a problem like this a lot with order of operations. They'll stick the 10 in there and they'll go, oh, so negative 10 squared? No, that negative in front is a multiplication. The exponent is an exponent. For order of operations, which do you do first? Multiplication or exponents? You do the exponents first. So if you do them in the wrong order, your sign's going to end up wrong. You'll end up with 100 rather than negative 100. So if I stick 10 in here, I get 100. 10 squared is 100. Put the negative in front, I get negative 100. Negative 100 plus 2 would be negative 98 divided by 8. So then you would just go from there. And they tell you, right, sometimes I get students that are like, oh, I'm putting in the answer and it's telling me it's wrong, but they're rounding to the wrong place. Make sure you read all the directions so that you know. They're saying here, round to the nearest 10,000th. And what does that mean? Remember, starting at the decimal. So if you start at the decimal and move to the right, you go tens, hundreds, thousandths, 10,000. So that's 4 decimal places. So, you know, it's a base 10 number system. So every time you move over 1, it's a power of 10. So tenths, hundredths, thousandths, 10,000ths, 4 decimal places, okay? And then just round to that spot, and you're good. Then we've got profit functions. Again, like, you're going to have to be comfortable with word problems, because that's essentially what this class is teaching you to do real world problems. And, you know, there's a saying in math, every problem is a word problem, because outside of a math textbook, everything you do mathematically will be a word problem, because it's a problem that has a bunch of information. It's described in different ways, and then you have to figure out what to do. Almost never in real life does someone come to you with an equation and say, solve this and get back to me. Like, that's not going to happen. You're going to be brought some problem, and someone says, figure out what we're supposed to do. And you figure it out, and then you give your recommendation. So let's look at this one. The revenue for a business as a function of units produced X is shown below by R of X. So that's revenue. C of X represents the cost by producing X units. Calculate the profit function, then determine how many units must be produced for the business to break even. Okay, so here's what you want to do. Here's how you do this problem. So let's do it over here. Well, I'll show you that in a minute when we're done with the problem. I keep doing my tabs in the wrong order. So we've got... R of X is, sorry, I heard something outside. I didn't know what it was. Oh, 7X. Okay, 7X. That's our revenue function. And our cost function is (3x plus 200). And there's our cost function. So if you're a business, your profit is your revenue minus your cost. In a business, revenue is the money coming in, cost is the money going out. So if you subtract the two, it tells you how much you have left, right? So your profit function is equal to revenue minus cost, which equals 7x minus 3x plus 200. Now, why did I put that in parentheses right there? I put in parentheses because this negative has to apply to both terms. We're going to have to distribute that negative in. If I don't, if I just left these parentheses off, the negative would only be applying to the 300, but we're subtracting the entire cost function. So we have to remember to subtract that off. And when I do that, I should be left with so 7x minus 3x will be 4x minus 200, right? Just distribute that negative in. You'll see that 7x minus 3x is 4x, and then you get minus 200. So that's our profit function. Now, what was the question? I don't even remember. Let's see. calculate the profit function, and then determine how many units must be produced for the business to break even. Okay, so break even in a business is where your revenue equals your cost. Because normally when you start a business, at the very beginning, before you've even made sales, you've spent money, which means in the very early days of your business, you're losing money. And the goal is to get to some point where you're making money. Well, that instant where your revenue equals your cost, that's where your business goes from losing money to making money. They call that the break-even point. If you're going to start a business, you need to know where that break-even point is, because if that break-even point is 2 months out, then you can go, yeah, I can afford to lose money for 2 months, and then I'll start making money. If it's 2 years out, you may go, I can't afford to lose money for 2 years, and then you don't start the business, right? But it's something you want to know before you just blindly rush into it. So they want to know, where's the break-even point? That's when our revenue equals our cost. So what do? You literally set your revenue equal to your cost. So in other words, the revenue equals the cost when 7x equals 3x minus 200. So then I'm going to subtract wait, that doesn't seem right, does it? Okay, anyways, let's go through with it. 4x equals negative 200. Did I get the function wrong? Oh, it's plus 200. No wonder. See, and this is a common mistake, so good lesson for you. I just made a common mistake that many of you will make. You're doing a homework problem, and you're putting the answer in. Like, I kind of caught ahead of time. This doesn't look like it's coming out right. But if you don't have that experience, students will keep putting the answer in and going, I swear I'm doing it right. What's wrong? One of the most common mistakes when students call me over when we're in a classroom and say, I feel like I'm doing it right, but I keep getting the wrong answer. It's because they wrote the problem down incorrectly, which I just did. The cost is supposed to be 3x plus 200, and I wrote it as 3x minus 200. I wrote it right up here, but then I remembered it wrong down here. So let me fix that. So that's just something to be aware of. If you keep working on something, you think you're doing it right, double check you're doing the right problem, because you might have wrote it down incorrectly. It's easy to do. I just did it. Okay, that means that x equals 50. Right, dividing 200 by 4, x equals 50. So then I come back and I put in my 50. And they go, yeah, good job. And you can see it's basically what I did. This even looks like I did with the parentheses and everything. And then we get down there, x equals 50, break even, good to go. This is what it looks like in graph form. Is we've got y equals 7x, and then y equals 3x plus 200. That's a big one, but if we zoom out enough, like a lot, you can see the green one's our cost function. Your cost function always starts off greater than your revenue function, because generally you have to pay money to start a business. You don't get revenue until you start selling product, usually, right? So the cost function starts off high, and they meet right here. And look at the x value right there. X equals 50. That's what we just found algebraically right here. So this is what it looks like algebraically. Graphically, it looks like this. Well, why don't we just always look at the graph? That seems easier. Well, a lot of times the numbers don't come out this clean. They can get kind of messy, and we generally want to solve for exact values. We don't want kind of guesses about rounding what it's going to be. We want to know exactly. Okay, so that's what that part looks like. So that is a big portion. Like this function portion is the one that causes people the most problems. And from the emails I've been getting between the two sections, this is I think that's still the case, is that piecewise functions really confuse people, but we're going to be reading them. We're going to be dealing with them. So make sure you're kind of comfortable with them. So try them out. See what you can do with them. Come to my office hours. Go to the tutoring center. Get help. Send me questions for next time if you have any. Preferably stuff that's not past due on the homework yet. Stuff that's still due. But we can do it either way. Those of you who haven't done any homework yet, make sure you get in there and do some homework so that I can make the case that you're progressing in the class. It'd be great if you could get 4 or 5 assignments done, but if you can't, make sure you get some scores in there. Don't go in and do one problem, because that's, I have to sit in front of the dean potentially and say, here's why I didn't drop this person. I have to be able to, it's real life. We can't just play like it's technicalities. But go in, do a legitimate amount of homework so I can make the case that you're progressing, and then I don't have to drop you from the course, because I don't particularly want to drop anybody. I feel like if people don't want to be in the class, they can drop themselves. But I have to drop people who aren't participating, okay? So go in and watch those, or go in and do those homeworks, watch the videos, and let me know if you have any questions or anything. So I'm going to close down the YouTube stream. I will leave Zoom open, so anyone who wants to talk to me, ask me a question, anything like that, please come into the Zoom meeting, and I will stick around as long as people are asking me questions and getting help. I'll help you with that, okay? Otherwise, good work. I'll see you next week. Please watch those due dates on the homework and make sure you're progressing so that you can get stuff done on time. All right, thanks, everybody.